Hello to all my wonderful chemistry students out there. We are going to start chapter 3. This is going to be the first of 3 podcasts for this chapter. And so in this one, we're going to talk a little bit again about elements, atoms, and ions, which we talked about some in the first 2 chapters and when I was showing you the demonstrations in class. And the first part of this section talks about the elements and the abundance of them. Now, I want you to think about of all the materials in the universe. Maybe just look around where you're sitting right now and listening to this podcast. Look at all the items that are around you, the things that you're holding onto, the things that you can look at. And they are all made with about 100 different elements. Now think about that. 100 different elements is making everything that we have in our universe. But we can also talk about that in terms of our alphabet. If you think about that, we have 26 letters in our alphabet, and we get this huge dictionary and this huge wealth of vocabulary and all these different languages from just a few simple letters. So the same thing should be able to be understood or make the comparison that if you have 100 different elements, we can make endless number of compounds, and that's where all our new materials are coming from today. So this right here is something that I want you guys to go ahead and read. So active reading questions, page 51, make sure you fill this in. And then complete the following review questions on page 55. You can see you're only doing question 2 and number 6. So that will be the end of section 3.1. So as we continue on to section 3.2, by now you've probably done a little bit of work on your period timelines of the atom. And we're talking a little bit about Dalton's atomic theory. And you have to think back that we didn't really know too much about the atom at this time. And he was the first one to even say there was such a thing as an atom. So in his theory, he had 4 highlights. And the first one says that all elements are composed of tiny, indivisible particles called atoms. So indivisible, meaning that they can't be separated. Well, we are still calling them atoms today. So this part of it is still true. So you can write down, yes, that this is still true today in terms of very, very tiny particles. However, the indivisible part that we have over here is not going to be true anymore today because we can split our atom, and you guys know that as fission, and that's what we're going to talk about when we get to our nuclear chapter. Point 2, atoms of the same element are identical still today. Well, the answer of that is going to be no. And we're going to talk about isotopes. We're going to do a lab with isotopes. And so we do know that atoms have the same protons, but they do not have to have the same number of neutrons. Therefore, their mass numbers can be different. In item number 3, atoms of different elements can physically mix in any ratio, chemically combine in whole number ratios or compounds. Is that still true today? And that answer is yes, it is. And we'll talk more about this, but something you could think about, water. It doesn't matter if water's here in Hastings, Minnesota, in our classroom, or halfway across the world, it's still always H2O. And if you take a look at H2O, we know that we are always going to have 2 hydrogens and 1 oxygen. And we'll look at that further when we start talking about compounds. Chemical reactions occur when atoms are separated, joined, and rearranged. Absolutely. You've seen that how many times in just the demonstrations that I have shown you thus far. They can be joined and separated and rearranged. So Dalton did a pretty good job actually without all the technology that we have now in explaining the atom. Step 5, atoms of one element are never changed in another. And this would be yes in terms of chemical reactions. However, the answer would be no if we're taking a look at nuclear reactions. So again, it's just been changing because of our technology changing and the things that we are able to do. So here's another assignment that is questioned here that I would like you to finish, and we can talk about some of it in class if you have any questions. Okay, that's section A. Now we're going to take a look at section B here. It says formulas of compounds. A distinct substance composed of atoms of 2 or more elements. So make sure you highlight 2 or more elements make up a compound. And we have already talked about that. A specific compound is always made of the same elements in the same ratio. And I just mentioned this also, that water is always going to be 2 hydrogens to every 1 oxygen. So I have 2 more review questions for you here. Make sure you take a look at that and bring any questions that you have to class. Okay, we just have a couple more slides here and then we'll be finished with this first podcast. So if we take a look here, I did this demonstration in class. This is the atomic structure of the atom in Thomson's experiment. And if you recall from your timeline that he was the one that discovered a negatively charged electron. And so you can see similarly that this diagram is showing you how they brought a magnet near it. And if this beam was not charged at all, it would have never attracted to the end of the magnet. And so because of the slight deflection that you see here, Thomson knew that there had to be something charged there. And we talked about that in class. Hopefully Miss Benson didn't get zapped because that's the part of this demonstration that I always worry about. Okay, Rutherford's experiment. Hopefully this rings a bell from your timeline also, and he talked about this Rutherford's experiment is called the gold foil experiment. You might want to write that down, gold foil experiment. And he had a source of beta particles, and so that's what that little fish looks for. Actually, it's alpha particles, sorry. This is an alpha particle. Excuse me for that. So I have an alpha particle here that's going through a lead source. And we did talk about this a little bit in class, that this lead is able to protect everyone and make the beam go straight through here. And so what he thought is these particles were going to hit a screen and he wouldn't really see any scattering. But what actually happened when he did this is he saw some of the particles being deflected and some were scattered. Well, if there's not anything called a nucleus in the middle, which you have to remember that Rutherford did not understand that at this point, then there's nothing to deflect off of. But what he actually saw is that wow, that's a little bug going across my screen there. You see that? What he actually saw, excuse me, is the experiment had some thing that it was bouncing off of. And so he was able to deduce that that had to be some sort of nucleus. And obviously it's very, very small. We know that the atom is incredibly small. If an atom were the size of the Metrodome, or Mall of America field as we call it now, the nucleus would be the size of a marble. So think about that vast place that's there. Even if you haven't been there, you can get an idea of it when you watch the Vikings on TV, that if you were to put a marble right here at the center, that would represent the nucleus. The rest of this would represent the electron cloud of the atom. Bring that all the way down in your brain. It's just incredible how small the atom is and how much space there really is. And so when we look back at this gold foil experiment, what he was able to deduce and understand that particles were being deflected, again, it's just mind-boggling how incredibly small this nucleus and the particles actually are. Okay, so that is the first section, the first podcast I wanted to finish here. Make sure that you go back and do all of the reading and finish up the questions that are throughout your notes. Have a wonderful day and looking forward to seeing you in class. You take care.